start our experiment, we watched the video provided in our Canvas and took down notes. We then proceeded to our actual experiment by using the PhET simulator Circuit Construction Kit DC as provided still in our Canvas. To make our complete circuit, we used the wire, battery, resistor, and a switch. To measure the current through the circuit, we used the ammeter, and a voltmeter was used for the voltages measurements. The voltage of the battery was decided by our group to be set 17 volts, which was equal for all 5 trials. The increasing values of the resistors were applied in each trial.
So for the first trial, with a resistance of 7 ohms, the voltmeter showed a value of 17 volts, and the current as shown by the ammeter was 2.43 amperes. For the second trial, with a resistance of 12 ohms, the voltmeter showed a value of 17 volts, and the current as shown by the ammeter was 1.42 amperes. And for the third trial, with a resistance of 22 ohms, the voltmeter showed a value of 17 volts, and the current as shown by the ammeter was 0.77 amperes. For the fourth trial, with a resistance of 27 ohms, the voltmeter showed a value of 17 volts, and the current as shown by the ammeter was 0.63 amperes. Lastly, for the fifth trial, with a resistance of 32 ohms, the voltmeter showed a value of 17 volts, and the current as shown by the ammeter was 0.53 amperes. So after gathering all these data, each of the values were recorded in our table.
To solve for the theoretical values of the voltage and current from trials 1 through 5, Ohm's law was used. For the voltage, it was the product of the current and the resistance. For the current, it was the voltage divided by the resistance. Solving the theoretical voltage for trial 1, 2.43 amperes multiplied to 7 ohms resulted in 17.01 volts. The theoretical current was 17 volts divided by 7 ohms, which was equal to 2.43 amperes. Solving the theoretical voltage for trial 2, 1.42 amperes multiplied to 12 ohms resulted in 17.04 volts. The theoretical current was 17 volts divided by 12 ohms, which was equal to 1.42 amperes. Solving the theoretical voltage for trial 3, 0.77 amperes multiplied to 22 ohms resulted in 16.94 volts. The theoretical current was 17 volts divided by 22 ohms, which was equal to 0.77 amperes. Solving the theoretical voltage for trial 4, 0.63 amperes multiplied to 27 ohms resulted in 17.01 volts. The theoretical current was 17 volts divided by 27 ohms, which was equal to 0.63 amperes. Solving the theoretical voltage for trial 5, 0.53 amperes multiplied to 32 ohms resulted in 16.96 volts. The theoretical current was 17 volts divided by 32 ohms, which was equal to 0.53 amperes. All of the data were recorded in our table.
Ohm's law is one of the most fundamental and important laws governing electrical and electronic circuits. It relates current, voltage, and resistance for a linear device. It allows you to determine characteristics of a circuit, such as how much current is flowing through it if you know the voltage of the battery in the circuit and how much resistance is in the circuit. It is used within all branches of electrical and electronic science and for calculating the value of resistors required in a circuit. And it can also be used for determining the current flowing in a circuit where the voltage can be measured easily across a known resistor. But more than this, Ohm's law is used in a vast number of calculations in all forms of an electrical and electronic circuit. Ohm's law states that the voltage or potential difference between 2 points is directly proportional to the current or electricity passing through the resistance and directly proportional to the resistance of the circuit. The formula for Ohm's law is V equals IR, where V is voltage in volts, I is current in amperes, and R is resistance in ohms.
The experiments showed that the current and resistance are directly proportional to the voltage. The current is directly proportional to the voltage and inversely proportional to the resistance. With a constant voltage, as the current increases, the resistance decreases. The resistance is directly proportional to the voltage and inversely proportional to the current. With a constant voltage, as the resistance increases, the current decreases. As the current increases, the resistance decreases. Using the Ohm's law formula, we have computed the values of theoretical voltage and current. The theoretical and experimental voltage had a negligible differences which range from 0.01 to 0.06, while the theoretical and experimental current arrived at exactly the same values.
It was observed from our experiment that the current is directly proportional to the voltage and inversely proportional to the resistance. This is very evident with the values recorded in our table. With the increasing value of resistance and a constant voltage, the current decreases and vice versa.
In conclusion, we have verified Ohm's law principle mathematically and via the FET simulator, which state that the voltage or potential difference between 2 points is directly proportional to the current or electricity passing through the resistance and directly proportional to the resistance of the circuit. Mathematically, it is V equals IR. The theoretical and experimental voltage had an insignificant difference, while the theoretical and experimental current arrived at precisely the same value.